Hi, welcome to engVid.com. I'm Adam. In today's video, I'm going to look at some math. Now, I know this is an English site. Don't worry, I'm not actually going to do any math. Philosophy and English major, so math not my favorite. But I will give you some math terminology, words that you need if you're going to do math. Now, a lot of you might be engineers or you might be students who came from another country to an English-speaking country, and you're going to math class, and you know the math, but you're not sure of the wording, okay? So this is what we're looking at, terminology. Only the words that you need to go into a math class or to do some math on your own, okay? We're gonna start with the very basics. You know all these functions already. I'm just gonna give you some ways to talk about them, and then we'll move on to some other functions and other parts. So, you know the four basic functions: addition, subtraction, multiplication, and division. What you need to know is ways to say an equation, right? You know an equation. 1 plus 1 equals 2, that's an equation. X squared plus y cubed equals z to the nth degree. That's also an equation, which I'm not even going to get into. So let's start with addition. The way to talk about addition, you can say 1 plus 1. Plus, of course, is this symbol. That's the plus symbol. 1 plus 1 equals 2. 2 means the total is also called the sum. Now, you can also say the sum of 1 and 1 is 2. You can also just say, without this part, 1 and 1 is 2. So you don't need the plus, you don't need the equal. You can use and is. But it means the same thing. Everybody will understand you're doing addition. Sorry, doing addition, not making. If you add 1 and 1, you get 2. Okay, so add and get. Other words you can use to express the equation. Now, if you're doing math problems are word problems. I know a lot of you have a hard time understanding the question because of the words. So different ways to look at these functions using different words, different verbs especially. If we look at subtraction, 10 minus 5 equals 5. 5, the answer, is also called the difference. For addition, it's the sum. For subtraction, it's difference. 10, comma, subtract 5 gives you 5. Or 10, deduct means take away 5. We can also say take 5 away. Oh, I forgot a word here, sorry. Take 5 away from 10, you get, okay? 10 subtract 5, you can say gives you 5. Sorry, I had to think about that. Maths, not my specialty. So, take 5 away from 5, you get 5. Take 5 away from 5, you're left with. Left with means what remains. Okay, so again, different ways to say the exact same thing. So if you see different math problems and different language, you can understand what they're saying. Okay? Multiplication. 5 times 5, that's 5 times 5 equals 25. 25 is the product. The answer to the multiplication, the product. 5 multiplied by 5. Don't forget the by. 5 multiplied by 5 is 25. Is, gives you, gets, etc. Then we go to division. 9 divided by 3 equals 3. 3, the answer, is called the quotient. This is a Q. I don't have a very pretty Q, but it's a Q. Quotient. Okay? 3 goes into 9 3 times. So you can reverse the order of the equation. Here, when in addition, subtraction, multiplication, well, actually in addition and multiplication, you can reverse the order and it says the same thing. Here, you have to reverse the order, goes into, as opposed to divided by. So pay attention to the prepositions as well. Gives you, 3 goes into 9 3 times. There's your answer. 10 divided by 4. Now, sometimes you get an uneven number. So 10 divided by 4 gives you 2 with a remainder of 2. So 2 remainder 2. Sometimes it'll be 2R2. You might see it like that. Okay? So these are the basic functions you have to look at. Now we're going to get into a little bit more complicated math things. We're going to look at fractions, exponents. We're going to look at some geometry issues, things like that. Okay, so now we're going to look at something else. We're going to look at fractions, exponents, and decimals. Again, all of you know these things, even from high school, even before high school, primary school, math, some of this stuff. A fraction is basically a partial number. It's not a whole number. It's a part of. That's why it's called a fraction. You have two parts to this fraction. You have the numerator, and then you have the bottom part, which is the denominator, numerator, denominator. Now, the thing to know about fractions, now how to add them, how to multiply them, that's a math lesson. We don't need to know that. We just need to know the words. What you might have some trouble with is pronunciation. So 5 over 12. We don't say 5 over 12. We say 5/12. So you have a lot of consonants here. 12ths. Now, keep in mind that even native English speakers have a hard time pronouncing this. So if you find it difficult, don't worry. In context, people will understand you. If you say 5/12ths, okay, I get it. If you say 5/12ths, I'll get it. I know what you're trying to say. 5/6ths, this one's even worse. XTHS, sixths. Just say it as close as you can, you'll be understood because people know you're talking about fractions, okay? On the other side, we can say like, this is a half, right? 1 over 2, so a half. We can say it in decimals as well. Decimals are the point form. So this is 0.5. I hope you can see this point here. We don't say 0.5. We don't say 0.5. Always point. Okay, 0.5. Now, 0.33, no. Because this is not a number. This is a partial number, just like a fraction. It's less than 1, so it's not 33. It's 0.33. And as many numbers as you have, 0.3, 3, 7, 8, 9, 10. Well, no 10, 1, 0. Okay? So, and you can go as many decimal places as you want. So this is a whole number. This is the decimal. 1, 2, 3, 4, 5, 6 decimal places. That's what we talk about after the decimal point. Okay? Now, this is the tenth or 1/10. Everything that's here. So if you have 0.3, you have 3/10ths of whatever it is you're talking about. 100th, 1000th, and then we go on from there. But we don't usually talk in these terms beyond the third. It gets a little bit more, too complicated. Now, 3, where does this number fit, first of all? 3 over 100. So first of all, it's here. Oh, no, it's not. That's thousandths. It's over here. Okay, so 300ths. 300ths. Now, if you just say, like in pizza, 300ths, close enough, then again, people will understand you. When you're talking about sports, for example, and they say there's like 0.5 seconds left on the clock, so the guy basketball, he shoots it, he scores with 1/10 of a second left in the game. So you understand, they're talking about 0.1 second. Okay. Next, we have exponents. X with a small 2 or small 3 or whatever number. So this whole thing is called, the 2 is actually called the exponent. The X or whatever number is called the base. And we can also refer to this as the power. So the whole thing is the exponent, base, and power. Now, when we talk about x to the power of 2, we don't say to the power of 2. When the number is 2, we say squared, so x squared. When we talk about 3, we say cubed, okay? So we're going to look in a second, we're going to look at measuring area of a shape or measuring the volume of a shape. Different shapes, of course, but area is measured with x2 or whatever the measurement is squared, and the volume is measured with cubed, okay? Now, once you get past the third, 4, 5, 6, there's two ways you can say it. You can say x to the 4th power. If this is a 4, x to the 4th power, or x to the power of 4. Now, sometimes you might hear this expression, the nth power. The nth power means unlimited. It goes on forever or infinite. We don't know where it ends. but this is actually an expression used in regular English as well. And we'll talk about that another time. Now, if you're going the opposite direction, instead of squaring the number, you want to find the root of the number. So 3 squared equals 9, okay? The square root of 9 is 3. How many times does 3 go into 9? 3 times, etc. Square root, finding out how many times the number goes into itself. X squared, multiplying the number by itself 2 times. Okay, so far so good, but we're not done yet. We still have to look at shapes and what to do with them and angles. A lot more interesting stuff coming up. One sec. Okay, so we're going to look at a couple more symbols and words before we go on to other more complicated things. I wanted to squeeze these in because they're a little bit simple, but still need to understand them. Average and mean. Now, average and mean are synonyms. They essentially mean the same thing. We use mean more with math. We use average more with other things, like everyday things as well. But they mean the same thing. So when you're looking for the average or the mean, you're taking all the values. So in this case, we have 1, 2, 3, 4 values. You add them up. You take the total and then divide it by the number of values you started with. So we have 4 values that total 20 divided by 4, and the average of these values is 5. Okay, so that's average or mean. Now, on the other hand, you want to sometimes look for the median. Now, in some situations, you don't want the mean or the average because the extremes, the top or the bottom, are so far apart that the average will not give you a right idea of what's going on with whatever values you're looking at. So what you want is the median. The median is more like the middle number that has an equal number of values above it and an equal number of values below it. So that's a little bit more representative of the situation you're looking at. Okay, so now we're going to look at these symbols. We got this one, this one, this one, and this one, 4 of them. Now, this one, when you have the bigger size open and then it goes to the smaller size, means y is larger than x. Larger, smaller, right? So y is larger than x, y is greater than x, y is more than x. Don't forget the than, because again, you have a comparative here. And if you turn it around, y is smaller than, y is less than x. Now, sometimes you might see these symbols with a line underneath, in which case y is greater than or equal to x, okay? Y is greater than or equal to x. Y is less than or equal to, y is less than or equal to x. And now this one, you have the equal sign, but then you have a squiggly line. This means it's approximately equal to. So it's an approximation, not exactly equal. And then you have the equal sign with a strike through. In this case, it's just not equal. Okay, pretty straightforward stuff. Let's move on to some other more complicated things. Okay, let's look at some more math stuff. We're going to look at shapes, okay? So first of all, we're going to start with a rectangle. It means that all 4 sides are not the same length. You have the width, you have the length, okay? Now, when you add a height or a depth, both okay, depending on what you're looking at, then first of all, you've created a box. So a rectangle is 2-dimensional. A box is 3-dimensional. Width, length, height, or depth, both okay. Now, when you measure these, basically you want to measure the inside space, then you're measuring the area. So you do length times width, and the answer is whatever the number is. So let's say you have 2 feet by 4 feet. So you have 8, and then the measure. If you're measuring in meters, in feet, in inches, in kilometers, whatever, and then you have the square. So whatever 20 meters square, 20 square meters, etc. When you add the 3rd dimension, now you're measuring volume and you're using the 3, the exponent 3 instead of the exponent 2, okay? Now, other shapes. We have a square. All 4 sides are equal. When you put in the extra measure, the extra side, and you have a depth to it, then you have a cube, okay? So, and again, another way to think about this is 2-dimensional, that's why it's squared. This is 3-dimensional, cubed. Okay. A circle or a sphere. Now I can't draw a sphere because I'm not a very good artist. Like if I do like this, like like a moon, like a ball is a sphere. The flat shape is the circle. If you want to measure the outside of the circle, then you're trying to measure the circumference. Sorry, I forgot to mention, if you want to measure the outside area of the rectangle, you're measuring the perimeter. Same for a square. For a circle, you're measuring the circumference. If you want to measure the volume of a sphere, then you're starting to get into things like radius. So a radius is from the center to one side. That's half the distance from side to side. If you want to go the full distance, then you have the diameter. Radius, diameter. Full length, basically cutting it in half, equal points. So that's the circle. Then you start, if you want to get into the actual measurements, then you start having to look at pi. Okay, just that's how it's spelled, pi, I think from Greek, if I'm not mistaken, the letter. Now, we're getting into triangles. We're going to look at triangles again in a minute, but for now, the two-dimensional triangle. Now, three-dimensional, you can have a pyramid. You can have the base, and then you have the sides coming up to an apex. Apex means top point of something. Or you could have a prism where you have the extra side on this side. Okay, so triangle, pyramid, prism. Then we have other shapes like oval. This is like a cone, like an ice cream cone. And there's a bunch of other shapes. There's a rhombus, there's a diamond, there's a hectagon, there's an octagon, all kinds of shapes. If you're not sure, basically you can punch in the word you want. Just get a math book or a Google Shapes, and you'll see all the different shapes that are available to you, both two-dimensional and three-dimensional. Okay, there's too many of them to list here. These are the basics. We're going to work with these. We're not done yet, though. There's still some more math stuff to come. We're going to look at the different types of triangles and the different angles that each of them will have. Okay? Okay, almost done. Don't worry. I know you're loving this math stuff, but we're almost done. We're going to look at some triangles and some angles next, okay? So there are different types of triangles. Isosceles triangle has two equal sides and two equal length sides and one that's different. An equilateral has all three sides equal length. By the way, just so you know, lateral means side, equi is equal or even, so equilateral. So equilateral, all three sides are even. And then when you have all three sides different length, we call this a scalene triangle. Now, for example, the isosceles or the scalene, or really much either of these two, can also be a right angle triangle. A right angle is this square here. It means 90 degrees. When you have a 90-degree angle and you want to measure its area, you have to use this line directly opposite to the right angle. And this line is called the hypotenuse. Hypotenuse. Okay? You use that to calculate. Now, when we're talking about triangles, or really any shape, like we can in a rectangle, in a box, in a rhombus, etc., we have angles. And when we talk about angles, we're talking about degrees. So a circle is 360 degrees. Now, if I have just a straight line, that's basically like the diameter of a circle. If you think of this as a circle, this is the diameter. So it's 180 degrees for a straight line. So we have 360, 180, and then we have 90. So when you have a line, when you have a square, when you have a straight line and another straight line directly on top of it making a square right angle, we call this a perpendicular line. This line is standing perpendicular to this line. Okay? We're going to get back to that in a second. Now, let's look at some other angles. If you have an angle that is less than 90 degrees, okay, I hope you can sort of see it in this diagram, less than 90 degrees, it's an acute angle. Acute. Not cute. Acute. Angle. Sorry, not a good one. If you have an angle that is more than 90 degrees, we call this an obtuse obtuse angle. And then if you have an angle that's more than 180, so for example, if I'm measuring this angle, it's more than 180 degrees, that's a reflex angle. So you have all these different angles to work with. Again, very important for those of you who are doing geometry and whatnot to know the names of these angles. Now here we have a perpendicular line. It means straight at 90 degrees or at a right angle to another line. If it's not at a 90-degree angle, then it's on a diagonal. So diagonal is less or more than 90 degrees, depends which way you're looking at it. Now, one last thing here, if you're looking at graphs, like I'm not going to get into the details of the math here, but these two lines, they intersect at this point. This is like usually the 0 point base, whatever. At this point, they intersect, cross. Now, generally, this is the x-axis. This is the y-axis. And you have, in this graph, you have two axes. Singular axis, plural axes. Okay, so you know these lines. And finally, we have parallel lines. Parallel lines are two lines that go in the same direction, but will never meet. Okay, so there's an equal distance between them, and that equal distance between them continues forever. They're running along the same direction, the same track. Apart from each other, they will never meet. Okay, so I think we've covered basically everything on this here. Now, before I finish, I just want to say one thing. I have just scratched the surface of math in this lesson. I know math is huge. It's a huge field. I don't pretend to know even a bit about it, but I wanted to give this to you as a starting point. From here, you can go on and do whatever maths you do, whatever specialty you have. If you need to get into more depth, more detailed math, you're going to have to look that up on your own because, again, I'm not going to be very helpful with the maths part of it. When you go to the forum at engvid.com to ask questions, please don't ask me any math questions. You can ask me about words. Don't ask me to do any equations or anything like that. Calculus, forget it. Algebra, geometry, trigonometry, whatever. Here are your basics, okay? If you have any questions, though, of course, do come to the engVid forum and ask them. There's also going to be a quiz where you can practice with some of these words. If you like this video, and I hope you did, please subscribe to my YouTube channel. And again, I hope you enjoyed it, and I'll see you again soon. Bye-bye.